So we just looked at percentiles in U2A3. This is U2A4. We're looking at measurements of central tendency. So we're looking at the middle of the data. Not really the middle. The middle itself is actually the median. But we're looking at the best way to describe data sometimes is to talk about the most common stuff, which is the mode. So if you got a bunch of kids in a class and you want to talk about how old they are, you might say, well, pretty much most of them are 17 years old. Okay, so that's one way to talk about it. The median is another way to talk about it. So if you have a bunch of kids in class and you got a couple 16-year-olds here and you got a couple 18-year-olds here, but most of them are the kids in the middle are 17, you might say, look, that's the median. Okay, it's the middle data. Or you might take all the ages together, add them up, and divide by the number of kids, and say that's the average data or the mean data. So they all work as far as describing central tendency. All of them have different uses, and not one's not better than the other really. They just look at different things. So real quick, the mean, the arithmetic average. So real easy. This stuff here in U2A4. There's two different parts here: sample mean and population mean. Don't get hung up on this. The main difference here is that this represents, so an X with a line over it represents the sample mean. The letter mu, the Greek letter mu, which makes the M sound, is the representation of the population mean. What's the difference? One, you're looking at a sample, so you're looking at just a piece of information, and the other one you're looking at the whole population. So in the population, you're looking at every piece of data. So if you have a class and you want to know, information about the class, and get the population mean of the class, you would look at everyone in the class, the entire population. If you're looking at the sample, you would just take a certain amount of kids from the class, and that's your sample. What's the difference? Nothing really. You just take all the data, you add it up. Okay, so summation notation, remember this? You add everything up, and then you just divide by the number of kids. Same thing here, just a little bit different. Different letters represent different things. N is the number of observation. Big N, sorry, is the number of observation in the population. Little n is the number of observations in the sample set. Okay, and besides that, there's really no difference for anything you've learned as far as mean goes in the past. Okay, we'll keep going here. So if you want to get the mean of this data, 6, 4, 10, 7, 3, add them all up. There's five pieces of there are 5 different test scores here. And we add them up, 6, 4, 10, 7, 3, and divide by 5. There is your mean. Okay, weighted mean, same sort of thing here. You could have a sample weighted mean or a population weighted mean. Again, no real difference really, except that you have a mu here and an X with a line over it here. So the way it works is this: when a weighted mean, you've probably done this in the past also. All that the difference between your regular mean and your weighted mean is when you look at the data that you have, it's not, you don't have the individual pieces of data. Okay, so here we have a bunch of scores and then we have the frequency that they take place. So if we had this written out like we did in the past, okay, in the other page, you would say that, look, here are the score of 45 and it happens 7 times. So what's that? 2, 4, 6, 7 times. And then I have a score of 50 and a score of 50 and a score of 50, and that happens 12 times. So it's the exact same thing, except we take this data now and it's been put into this table. Okay, so now we have 7 scores of 45, 12 scores of 50, all the way up to 8 scores of 85. So if you want to know what the average score is, you can't just take these scores here and divide by what, 1, 2, 3, 4, 5, 6, 7, 8, 9, because different scores come up in different frequencies. For example, the most common is this guy right here. 73 people have a score of 60. Okay, so there are a lot more people going to have a score of 60 than have a score of 45. So you can't give them the equal weight. Hence the weighted mean. So all you do is this: you go 45 times 7. So what you'll do is you take the score and you multiply it by the frequency. So you take the data amount and multiply it by the frequency. So I have 7 people with a score of 45. 7 people with a score of 45, 12 people with a score of 50, and you'll multiply each of these, add them all together, and divide by the number of people in total. Now, in this case, you're not told what the total is, so if you want to find the frequency, that's what's happening here. There are 7 here, 12, add all these up, and you get, what, 300 here. So all this 300 is the number of people that have taken the test, okay? And there's your mean, okay? So again, it's sample, so it looks like this. If it was a population, the only difference would be this: you would have a big N again instead of a small n when you do the work. Okay. just a note here, and mathematicians, some people call us, no, I will not even call us lazy, but some people might call us lazy. I say we're efficient, okay? No, we are efficient, okay? And what we're doing here is this. These dot marks here and these dot marks here are completely acceptable. If you're telling me what if I show you that I go 7 times 45, 12 times 50, dot, 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 8 times 85, I know that what's missing is all this junk in the middle here, okay? You're going to kind of assume that I know where you're going with this, okay? And same with this. You don't need to write everything out, and that's what it's saying here. And this is completely acceptable, okay? If you want data grouped by value, so this is going to get cut off here. The mean of data grouped by value is used when data is presented using a frequency distribution, so class intervals. So, and then we're going to worry about the midpoints. So what does that mean? That means we're going to do this and this, okay, which might not make sense to you. One really cool thing is this. What we're finding out is the mean and the mean, okay, so again, sample and population, x mu. And what is really cool is this thing here. So if you look at this, this says x, the mean is, and it looks like it's kind of an equal sign, and that's what it means. It means kind of equal to, or approximated by this here. So what you're going to do now is when you have data that is given in a table, so it's only when you have a table like this, you're going to use the midpoints, okay? So I don't know. I have 4 people that have a height between 150 and 155. Now, what is the height of these 4 people? I don't know, okay? Could they all be 150, 150, 150, 150? Sure. Could they all be 155, 155, 150, or sorry, to just under 155? Could they be 154.9, 154.9, 154.9, all the way through? Sure. Okay, I don't know from the table. So when you do something like this and you find the mean for data given on a table like this, it will not be exact. Okay, so just have that out there. And all you're going to do is say, all you do is say this. Okay, and it probably makes sense to you, is instead of doing a frequency table like we did before, okay, using the mean on this frequency table, let me show you here, where you have the exact score, 45. Okay, so this is a score of 45 on the nose. So 7 times 45, right? What you'll do is you'll just take the midpoint of, okay, so I got cut off here. So you just take the midpoint here of all these groups here. So from 160 to 165, the middle is 162.5. So you just take these two numbers and divide by 2. Okay, 160 plus 165, divide by 2. The middle is 162.5. And then you go ahead and you do basically the same thing as you did with the weighted mean. Okay, so here, the last one here is 4 people at 177.5. That's our best guess for 175 to 180. So that goes here, and you get the weighted, you get the mean that is equivalent or close to the weighted mean. Okay, so again, you got this little cool symbol here. The median, okay, so the median is the middle position. Okay, the median is the value that occupies halfway point in the data. So here we represent that by the other day we were talking about the 50 percentile, so that's what we're doing here. We're just talking about the median, no special situation here. The median is just the 50th percentile. Okay, so here's a bunch of employees, and they have an hourly wage of 8, 9, 12, 17, 18 bucks. And you want to ask, the question is this: what is the median wage? Okay, and I know you know what it is. Okay, you can figure it out easily. But what you want to do is use this from the other day, n plus 1 over 100 times x. So to find the x position, okay, you want to use this. Okay, so to find the 50th percentile, okay, or the 50th percentile position, what you want to do is go through it and say n plus 1. In this case, there are 5 pieces of data, so 5 plus 1 divided by 100 times 50, because this is the 50th percentile, and you want the 3rd position. Okay, so then you go back at the data. Let's see if I can get this here. And you go back at the data once it's ordered, and you say, look, the 3rd person here is the middle value here. Okay, now obviously this was easy, but and usually median is actually easy. Okay, if you take the time to list all the info in the middle, and you don't need to do all this. Okay, if you have this list like this and say, look, that's the middle value, you don't need to tell me that's P50, etc. Okay, just know this: if there's 2 pieces in the middle, so if we had another guy here who was making 20 bucks an hour, what you do is you have, so that's the lowest, that's the highest, that's the second lowest, that's the second highest. These are the 2 middle. Take these 2, add them together, divide by 2, and get the average. Okay, so that's your median when there is an even amount of data. Okay, and you can see that in the work we did on percentiles the other day. So what happens here now is sometimes data is not shown the same way. You know, you don't get the individual data. You have a table of data like this, and you might have more than one person getting, having an attribute. So in this case, we're looking at test scores, and then just reading this quickly, very simply, 3 people have a score of 4, 45 people have a score of 7, and you say, what's the middle value of this? So this one's a little bit more difficult. You can probably work this out, okay? You could say 3 here, that's 20, and there's about this, and we're going to end up somewhere around here, okay? That's one way to do it, which is not probably the best way to do it. The first thing you want to do is figure out what the middle position is. So if you have 120 people, the middle position is 60.5. Now, how do you get 120 people here? It is you add all these up together. Okay, so there's 100. This is equal to 120. And if you go, no, the middle is 60. Just be careful on this, right? If I said to you, there are 4 people, right? So there's person 1, 2, 3, and 4, and you said, well, half of 4 is 2, so it's the second position is the middle. Well, no, it's not. Okay, the second position is close to the middle, but the middle is between 2 and 3. So, and every time you have an even amount here, even amount of data or an even population or sample, you're going to have a fraction for your position. Okay, so now what you do is, and this is a lot of work, you start figuring out who is the 60.5 person. Okay, that sounded weird. Okay, but you just start going through this, and the way they did it below is fine, but you can look at this and say there's 3, that's 20 now. I'm at 44. Okay, so 44 people are below here, and if I go into this group here, now I'm going to be at 89 when I'm done. 60 and a half or 60, 60, 61 is right in here, so the median is there. So I think I made that. I think most of you could have figured that out without using all the formulas, and that's fine. Okay, if you can do that with the median, there's no reason to make a big deal about it. The mode is just the most common. And then you can talk about this sort of thing here. What is the measure? Which one should you use? And it all depends. Okay, it really depends on the data. If you have skewed or symmetrical or outliers. If you have an outlier, a lot of times the median is the best thing to do. So this happens when I teach a class. I get my class average, and the class average is the class median is 80, but the class average is 72. And you look at it and go, well, why is that the case? Well, usually what happens is there's a kid or two in the class that has essentially dropped the class, and they don't show up. Or so if I have a couple kids with a 0 and a 2 as their marks, it'll pull down your average, but it has less effect on the median. Okay, so that's why the median sometimes is a better measurement of data. Another thing you do is get rid of the outliers too, and then figure out the mean, the median, and the mode with the outliers that are gone. That's only if the outliers are real outliers. Sometimes a kid who has a 2 is a kid that shows up and isn't doing well, and their data should count also. Symmetrical, the mean and the median are very close to the middle. So if you have what's called a bell curve, we'll talk more about that later. The mean and the median will be very close, so it doesn't really matter. And then if you're talking about frequency is the most important measure, you can look at mode. Okay, and mode I think is underrated as a way to talk about that, because I think we do talk about that in a way. If I said to you, what is the average age of somebody who's getting the license, you would, or tell me about someone who's getting the license, you would probably say 16-year-old, okay, or 17-year-old, because you wouldn't get all the data, add it together, and divide by the number of people. You wouldn't, get the median. You would just say, well, most of the people that I know are 16 or 17. Okay, so that would be a way that mode is used. Okay, so that's about it. I don't think it's that difficult. It should be pretty straightforward. Hopefully you get it. If not, especially about the mean stuff, you get a little confused about the symbols and that sort of thing. Come and send me an email. Okay, take care.